Okay, so let's go over and take a look at what gets produced. So if we look here, here's the data, the median height weight data from the CDC. We created the X and the Y objects that are going to be of class infant. And we know once we run these two commands, we know they are of class infant. Of course, I can validate that by running these two class commands and it reports back infant. So that just confirms. If we print those results, you see it right there, but I'll print it out again. We see the data formatted according to the print definition for that infant class. Notice I can take a look. Let's just take a look at what our print definition looks like also. So notice if I run these objects all together, there we go. Finally got it to run. I was messing up somewhere there. It's going to show that it's a generic print function, just like we defined. But when it operates on these XY objects, it does a very specific thing, which is print out the data according to, in this data frame, formatted object. So we get age, height, and weight in that order with those labels. Then finally, if I run the plot commands, I get these curves over here. So this is going to give, let me go over to the original. There we go. First the male. So notice the title to subject 1, male, and we get the height and weight curves. Then we can scroll through and see subject 2, female. Again, we see that 2 by 2, so we get 2 vertically aligned plots within our plotting window that look just like those growth curves that you get at the doctor. Let's look at one of the weaknesses of S3 classes. It's possible to create invalid objects using these S3 classes. For example, we could run a new subject, so this will be ID number 3, who will be a male, and we're going to assign this information to that male. So notice we have, instead of having particular months that are numeric, that would be a numeric vector, we have a character string vector. So it's going to be really difficult to plot that in a graphical object the way we have it defined. So let's take a look at what happens. By the way, we have 2 observations, one observation at 0 and one observation at 3 months old, and then their respective weights and heights here. So these are actually okay, the height and the weight. But let's see what happens over here when we try to run this. Or when we run this, actually, let me start over. I will have no problem. And in fact, I could add to this at the bottom here. I could add to this, check the class, and it would look like everything is okay. Let's take a look at what happens if I print the class. Looks okay. I'm seeing everything the way I want. We can tell that right here, age is character string. And let's take a look at what happens if I plot it. Here's where we have some problem. Okay, so notice this isn't creating the kind of plot we wanted, and what is the trouble? We do not have a numeric vector here for age. And so plot will operate on it, but it doesn't operate the way we intended anymore. So you can have these mix-ups, so to say, using S3 objects, because there's nothing, a well-defined class within R should have not allowed you to run this line. And S3 class is informal enough, it just lets you do it anyway. So let's move on. So remember that odds ratio function we wrote some time back? This function had a print function in it that would return a list object of the results invisibly, but you could print it out using the cat function, okay? So we could use this function call over and over and over and get results printed in this way. We could, at times, say we're using it in a simulation, it's going to print over and over. And we really don't want those printed results in our console window if you're doing it, say, 10,000 times. That's really a waste of resources. So one possible approach is to suppress your printed input using an indicator function. You can use an if-then-else argument to print or not print, or better yet, if-else argument to print or not print the output. A better way, though, is to just make use of S3 classes. So remember that an unassigned function will print the value returned, and that assigned functions, on the other hand, won't print anything. So instead of just including that print statement within the function body that we have done in the past lectures, let's just assign a class name to that object and write a print method associated with that class object. Or object class, I should say. This way, it's going to show you what we want, but we have to command using just a call of the object with that particular class for it to print. So if we don't want it to print, it won't, if we just don't call it that way. So let's look. Here's the original. Okay, this is how we did it. Recall we had this cat statement that reported out the results so we could visually see what happened. Of course, that list object is what's contained within any time we store an odds ratio function object within another object in R. Here's how we could use an indicator argument. So this would be one way to fix this, okay? So here we have a quietly indicator argument, and its default value is false. So it's not going to print anything unless it's not going to print anything if we keep this alone. But if we say quietly equal true, then it will print. No, I got that backwards. If it says quietly equal false, it will print. I had that backwards in my head for a moment. So when quietly is false, then this would be true when we put the exclamation sign in front, and then it'll print out the results. And we still get the list object that actually contains our information from the calculations done in this function. Here's how we could use it using an S3 class, though. This is, in my opinion, the best. We still have these same objects up here that are kind of verification warning arguments to just make sure we have everything in the function call that we should. Okay, we still have the list object. Notice that the cat statement is missing now. And what we've done is we've simply replaced the cat statement down here in the definition of the print function for the OR object. So here we're going to have an odds ratio class object, and it'll do these calculations just like our old function did. And then we can define, how do we print for an odds ratio class object? Well, here's the definition. So if we have an object X, and notice what X is, we have the contingency table, the 2x2 contingency table. We have placebo versus aspirin, and whether or not they had a myocardial infarction, yes or no. This is the same data we saw before. We can run it with the odds. This is the original odds ratio data, and this is what was by default printed. So imagine you're running this in a simulation. You would see, if you have 10,000 iterations of your simulation, you're going to see this in blue 10,000 times, which you don't want to see. Even if you define it and assign it to an object, you'll still see that cat statement printed out because of the cat statement. Versus using the indicator argument, if it's false, it's only going to be printed if quietly equals false. So we see the same thing. It's just we can now have the option of making quietly equal true, and we won't see what's in blue there. Versus if we have odds ratio class and we define it and then print the object, then we get the same results, but we have to make a call to print it. I noticed we were missing that last line. I had to get out of full view here. So we get the result for odds ratio contained in this object here. And we would have to print that to see it. Okay, so now we're going to start on S4 classes. Let's wait for the next set of notes in the next week to do this.